Hey guys, this is the help video for the Exponent Basics quiz part 1. And we might have time to fit part 2 in at the end, I'm not really sure yet. So this first one says, what is the sum of 5/6 plus 1/3? Now remember, when you add or subtract fractions, you have to have a common denominator. So if we wanted to solve this by hand, we would have to get a common denominator. If I look at 6 and 3, 6 is actually my least common denominator. So I ask myself, what do I need to multiply 3 by in order to make it a 6? And in this case, you'd have to do 3 times 2. But whatever you do to the bottom, you have to also do to the top. So I'm rewriting this as, well, 1 times 2 is 2, and 3 times 2 is 6. So I've taken this fraction of 1/3, and I've just rewritten it as an equivalent fraction. So I'm going to rewrite this. Now I have 5/6 plus 2/6. Since I do have a common denominator now, I can go ahead and add. The denominator stays the same, and for the numerator, you add them together. So 5 plus 2 is 7. So this equals 7/6. Now, if it's multiple choice, it might not be written as an improper fraction. They might write it as a mixed number. So to convert to a mixed number, you have to ask yourselves, how many times does 6 go into 7? 6 goes into 7 one time, and there is 1 left over. So 1 time for how many times it goes in, and then however many are left over goes on the top. So you could write this either way. This could be your answer, or this just depends on how the multiple choice questions are written. Now, just as a reminder, you can do all of this in Desmos. So let me show you that. 5/6 plus 1/3. All you have to remember when you put it in Desmos is each fraction gets its own parentheses. So parentheses, 5 divided by 6, close parentheses, plus parentheses, 1 divided by 3, close parentheses. So it gives our answer as a decimal, but we probably don't want it as a decimal, so we can convert it to a fraction using that fraction button. So you can get it in Desmos just like you can solve it by hand. Whichever way you're more comfortable, please use. All right, Sylvia has 6.5 boxes of chocolate to share at a family picnic. If she gives each person 1/2 of the boxes, how many people receive chocolates? So since she's giving each person half of a box, basically what we're doing is we're dividing each box in half. There's a couple ways that we could do this. One way is just to think through it. Like some of you guys might just automatically be able to say, okay, if she has 6 and then a half of a box, 6.5, and she wants to give each person half a box, well, some of y'all might be able to say, okay, well, if we split each of these boxes in half, that one's already a half. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. She would be able to give 13 people candy from the boxes or chocolates from the boxes. So some of y'all might be able to think of it like that. You can also do it with math operations. We are going to take 6.5 and we're going to divide each box, right? We're trying to divide each box. We're trying to cut each box in half. And when you divide, remember you do keep, change, flip. So you keep the first one the same. I'm going to go ahead and convert this to an improper fraction. So 6 times 2 is 12 plus 1 is 13. 6.5 is the same thing as 13 over 2. And when we divide with fractions, we keep the first fraction the same. We flip the sign to multiplication. We keep, change, flip. We change the sign to multiplication, and then we flip our second fraction. So if we did this with division, keep, change, flip, we would get 26 over 2, and 26 over 2 equals 13. So you can either use division, or you can think about dividing each box. Either way, you get 13. And just as a reminder, you can just type that in Desmos. So if we did 13, oops, let me clear this out. 13 divided by 2, close parentheses, and I wanted to divide that by the fraction 1 divided by 2. And it will give you the answer is 13. So I'm showing you by hand and I'm showing you the calculator. I do not care which method you choose, as long as you can get it correct. All right, which of these numbers is not rational? Well, if it's not rational, that means it's going to be irrational. And remember, irrational are those numbers that go on forever, they don't end, and they don't repeat. So the easiest way for me to do this is to change each of these to decimals. And the way I'm going to do that is with my calculator. So I'm going to go over here and I'm going to type in square root of 3. And it gives me this really long number. Well, that I can already tell it doesn't end and it doesn't repeat. So that is going to be my not rational answer. But I'm going to go ahead and show you the rest of them too. 0.25 is already a decimal. So if I wanted to change 1/5 to a decimal, I would go over here and I would do 1 divided by 5. That decimal does end. It's a nice, pretty decimal. And then the square root of 9, if I wanted to change that to a decimal, then I would do square root 9, and that equals 3. So the only one that is irrational or not rational was the square root of 3. Which symbol will make the number sentence true? All right, so we're comparing 9 over 11 to 0.82. Again, I like to convert everything to fractions. I can deal with fractions easier than I can. I like to convert everything to decimals. I am speaking crazy today. So I'm going to take 9 divided by 11 and see what that equals as a decimal. Decimals are easy for me than fractions. So that's 0.8181 repeating. All right, let me go back over here. I'm going to rewrite this fraction as 0.8181, and that just keeps on repeating. And then I'm going to ask myself, okay, are they equal or is one bigger than the other? And in this case, they're definitely not equal. They're really close together, but they are not equal. If we thought about rounding this, like we would look, if we wanted to round to this decimal place, we would look at the number behind it, and that would make it round up to 0.82. So they're very close, but that does not make them equal. 0.8181 is less than 0.82. If you think about money, if you had 81 cents or 82 cents, 82 is bigger. And when we do inequality symbols, we want the alligator mouth to eat the bigger number. So we are going to use that symbol. Which expression is equivalent to this? Okay, so we're multiplying the same number over and over and over and over and over again. We can rewrite that using an exponent. The exponent just tells us how many times we're multiplying that number. So if we take 4 and we count how many there are, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. If I rewrite this as 4 to the 9th power, that tells me to multiply 4 9 times, which is exactly what we're doing here. So I would rewrite that as 4 to the 9th power. All right, Deborah has 2/5 of a pound of loose green tea leaves. If she wants to keep one half, I'm going to go ahead and rewrite that as a number. 1/2 of the tea at home and the other half at work. Again, I'm just going to rewrite that. What fraction of a pound will she have at work? All right. Excuse me. I immediately think of three different ways to solve this problem. The first way is if I have 2/5 and I want to cut that in half, if I have 2 of something and I want to make it half of that, I could convert this to 1/5 and another 1/5. Half of 2/5 is 1/5. So you could think of it that way. You could say 1/5 plus 1/5 equals 2/5. So if I wanted to divide that in half, I would just use that. That's kind of the logical way to think of it. Or you could say 2/5, we want half of 2/5, and half of 2/5 means 2/5 times 1/2. You could think of it this way. You would get 2 over 10, which reduces to 1/5. Or you could say, okay, if I'm getting half of it, I want to divide it by 2. So you could say 2/5 divided by 2. Any way you do this, you're going to get your final answer is 1/5. Half of 2/5 is 1/5. All right, 7 minus 3/7. Since we're subtracting, you would need common denominators, but honestly, my initial reaction is to type it in the calculator. So that's what I'm going to do. So I'm going to do 7 minus, and then since 3/7 is a fraction, we have to make sure we put it in parentheses. So 3 divided by 7, close our parentheses. It gives me this decimal, but remember your calculator can convert it to a fraction for you. So the reduced fraction is 46/7. So this will equal 46/7. That's a perfectly appropriate answer. But your answer might be written as a mixed number. So let's just review how to do that. We're going to ask ourselves, how many times does 7 go into 46? And another way you could think about this is if you look back here at the decimal, see how 6 is your whole number? We know that 6 is going to be the whole number. So we know that 7 is going to go into 46 6 times. And 7 times 6 is 42. And we have 4 as our remainder. So if we wanted to rewrite this, 6 is our whole number, 4 is our remainder, and the denominator stays the same. So either one of these answers would work. All right, which of the following expressions is equivalent to -3 raised to the 5th power? Goodness, my computer's going crazy. So the 5th power just tells us how many times we are doing something. So we are taking this -3 and we are multiplying it out 5 times. 1, 2, 3. Wow, that's supposed to be a dot. 4, 5. We are multiplying that 5 times. So it might be written like this. It may also be written as, like it might have the, since it's a negative number, it might put those in parentheses. It doesn't matter. All that matters is that you have the base, which is -3, and you are multiplying it out 5 times because that's what your exponent tells you to do. All right, describe how to use the area model to find the quotient 2/3 divided by 3/5. Okay, so for the area model, you basically take a giant rectangle. To start off with, you're going to look at your first denominator, which is 3. And I'm going to divide it into 3 pieces vertically. So now I have 1, 2, 3 pieces vertically because my denominator is 3. And then I look at my next denominator and I have 5. So horizontally, I want to divide that into 5 pieces. And it doesn't matter if these pieces are even or not. We're just kind of trying our best. So let me make sure this is 1, 2, 3, 4, 5. All right. So you start off by dividing it. The first denominator gives you the vertical columns and the second denominator gives you the horizontal columns. Then you're going to look back at this first fraction. You want 2 of the 3. So we want to circle or highlight or something 2 out of the 3 columns. So I'm just going to go through and shade in. We want to get 2 out of the 3, and you can shade it all at once if you want to. It doesn't matter. You just want to shade in or mark somehow that you want 2 out of the 3. All right, and then we do the same thing for the blue. We want 3 out of 5. I'm going to go ahead and just circle these because it got really messy with the shading. So I want 3 of those pieces out of the 5 total. Okay, and then to write your answer, so when you go to write your answer of this division problem, the top number is going to be how much you shaded in red, and then the bottom number is going to be how much you shaded or circled in blue. So if we look at the red, we shaded 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we look at the blue, we shaded 1, 2, 3, 4, 5, 6, 7, 8, 9. So using the area model, we would get the answer as 10/9. Now you also want to show it using numerical operations only. So if we did it just using numbers, we could do this in Desmos. 2/3 divided by 3/5. So parentheses, 2 divided by 3, close parentheses, divided by parentheses, 3 divided by 5, close parentheses. And you would still get 10/9. Really quick, the last thing I wanted to show you is if you did keep, change, flip, you keep the first fraction the same, you change this to multiplication, and then you flip your second fraction, and you would also get 10/9. So I've shown you how to use the area model, how to use Desmos, and how to do it with numerical calculations. Good luck!